Hello everyone. So that day I have started with the integration and I have done some problems based on normal one. So today our next topic, that is topic 2. So we will do some problems based on substitution. It is called integration by substitution method. Substitution means what? Directly I can't apply the formula, but with the help of something, that is I will consider something, then you can apply the formula. That is the motive of substitution. So it means directly you can't. So with the help of some logic or some factor you can apply. So let me start with a small simple examples, then you'll get the idea when to apply this method and how to apply this method, right? But see, ultimate thing is that if you are applying the methods, right, your main motive should what? Convert the integral in terms of formula. So that directly you can apply the formula, right? Now see, let me start the small one. Suppose they have given this one, x square plus 1 and 2x dx. This is the first question they have given. Is this clear to you? Now see, here the first topic that I have you can't apply the formula directly, but there is a topic. See, under this topic now, so what is the main topic? Topic is that you have to identify whose derivative is there. If someone can find that the derivative of something is there, you can easily solve this topic. Clear? Now see, it's clearly visible that the down one is what? X square plus 1. So if I differentiate x square plus 1, that is if I do roughly dx of x square plus 1, right? You know dx of x square how much? 2x. Dx of 1 how much? 0. So ultimately 2x is there. Clear? Now see, derivative of this is there in the up. Is this clear? That means whenever you are getting this substitution, whenever that something derivative is there in the integration. Clear? That means you have to apply substitution. Clear? Now, see later I show you another topic. So here I am taking a derivative of down is there down. So you can apply another method. So but not now. But my motivation to show you which one is substitution method, right? So I have got the idea that the derivative this is there. So let us consider that x square plus 1 is equal to t. I have considered that this whole thing I will convert in terms of t. So this one I have converted. Now I have to find out the value of dx. So what I do? Dx of x square plus 1 is equal to dt. Is this clear to you? Yeah. Now you tell me dx of x square how much? 2x, and dx of 1 is how much? 0. So nothing you can take. And at the end you write dx equal to dt. Is this clear? Now you check whether this term is there or not. Yes, is there. So no problem. If it is not there, you can adjust. Just remember one thing, right? Constants and plus minus. Anytime you can adjust. But main thing is that whether this variable, this x and x is there or not. This is the main thing, right? Now if I put here, so the first thing is that the one you take it left. First to put that left. This one consider left. So write 1 by t. Then now what left? 2x dx. Now 2x dx means how much? See here. So this is the motive. Then after converting this equation into what we have substitution, I have converted this one. I have converted this form. Now this is the direct formula. So integration of 1 by x dx. Here is integration of 1 by dt means what? Log t. Then you write plus c. Now as the main equation is in terms of x, so I have to convert x t in terms of x. So t means what? X square plus 1 plus. See, the method is very easy. So your main motive is to what? Convert it into the formula so that you can apply this. And out to the first question. So let me start with the second one. Suppose the second one is suppose they have e to the power x plus e to the power minus x, then e to the power x minus e to the power minus x dx. This is the second question. It's clear? So let me identify that whether anything you are getting whose derivative is there. Yeah. Now see, if I take this one, derivative of this is what? E to the power x minus the minus x is there down. So the problem is there because the derivative whose there it should be always it should be in the numerator. It should be the numerator, right? So I can't consider the upper one. So I will not take this one. So only one option left, the down one. Left. Now take simple example. If I take dx of e to the power x minus e to the power minus x. So dx of e to the power x means what? E to the power x, right? Minus dx of e to the power minus x, right? Is how much? Minus e to the power minus x. It means what? E to the power x minus x plus e to the power minus x. See, this term is there. Clear? So we are getting the idea that the derivative of this is there now. So based on that, what I am considering left, I am considering e to the power x plus minus minus x equal to t. I have considered. Now differentiate both sides. Ddx of e to the power x minus e to the power minus x equal to dt. Now ddx of e to the power x, how much? E to the power x, right? Minus 50. Now ddx of e to the power minus x. This means minus e to the power minus x. So minus minus how much? Plus, right? Now after that you write dx equal to dt. Then now the one you have considered first, left, you write the first one. So 1 by something is there. So what I do? 1 by t. And see these things is there where. So it will be what? dt. See here also you can apply what? Log. Right? So answer is what? Log of t plus c. Now convert t. T means what? T means what? E to the power x minus e to the power minus x plus c. See, very simple, very easy. Second one done. Clear? So this is the process. Only to identify whose derivative is there. If somehow you have identified the derivative, this is there, you can easily solve. That's it. Finish. Now let me start with another one. Then get the idea. So let me third one is suppose this one. Suppose 1 plus sin x whole square. Then here at minus cos x dx. I am considering. Clear? Here also first to check whether you can apply the direct formula or not. I can't apply the direct formula. Now next process to identify whether I can apply any substitution method or not. So the best idea is identify whose derivative is there. Now see, I already told you that the derivative should be always in the R, so that you can easily write. Sometimes it will be doubt also, no problem. But the derivative should be there in the integration itself. Now see, if I consider this, the inside one. So what I do? Let us consider 1 plus sin x equal to t. Now you may ask how I have considered. How do I know? See, if I differentiate dx of 1 is 0, no problem. Dx of sin x is how much? Cos x. Clear? See down. Now you may ask minus is there. No problem. Already I told you now. Minus and constant anytime you can adjust. No problem is there. Right? Now I have identified. So based on that I have identified that derivative this is there. So written. Now my motivation to find out dx. So what I do? Differentiate, right? Both sides equal to x. Done. Now see dx of 1. How much? 0. Dx sin x how much? Cos x dx equal to how much? dt. Clear? It out. Now see here minus is there now. You can take outside. No problem. Right? Now the one if you can consider, write this one. So this is considered. So this is what? 1 by t square. Now what left? Cos x dx. Now cos x dx how much? dt. Clear? Now see this. There is a no direct formula for this, but I can adjust one thing. That this t is there down. If I take r, it will be what? It will be minus 2 dt. Is this clear? Now which formula? There is a formula now. Integration of x to the power n dx. What's the formula? X to the power n plus 1 by n plus 1. So let me start with this. So what is the formula? T to the power minus 2 plus 1 by minus 2 plus 1 plus c. So ultimately what you are getting? Minus t to the power how much? Minus 1 by minus 1 plus c. Now minus minus how much? Plus. So 1 by t plus c. Now put the value of t. T means how much? C. 1 plus sin x plus. So this dance. See. So this is the way you can easily solve. So let me give another problem. Right. So similarly you can solve all the questions. Let me say another one. Then get the idea. So let me start with suppose. Let me frame. Suppose log of x to the power 4 is there na? Take this is 4x cube. This is suppose x cube is there, then dx. Suppose this is given. This one I have given, and I have to identify whose derivative is there. Now see, it's clearly visible that the derivative of this one is there in here. This is the thing. But whenever you get the question, right, first you identify which method have to apply, then according to follow. So till now I have done two methods, the normal one and the topic two. That is substitution. That's our explanation. But slowly I'll show you when to apply which method. Right? Now see, let's play element derivative. This is how much? 4x cube. Okay, don't go for 4, but x cube is there. Na? Clear? Because 4 and minus plus easily can identify. What? Adjust. So let me consider that x to the power 4 equal to t. Is this clear to you? Now what will do? Ddx of x to the power 4 equal to dt. Now ddx of first form is what? 4x cube. Then you write dx equal to d. Is this clear to you? Now you check whether this expression is there or not. Everything is there, only 4 is not there. So shift it to that side. So if I shift it to what? X cube dx equal to how much? dt by 4. Now put accordingly. So the one you consider left. Put this one. So dx of log, right? So log, right? Log what? T, right? Then x cube dx, right? This is how much? dt by 4. So 1 by 4 is cancelled out. Then what left? Integration of log t dt. Is this clear? Now, here my topic is to show substitution method, right? But ultimately we are getting situation into it. I can't apply the formula directly. That means here we will do another method, right? So later on, whenever I started the topic, I'll start the topic. It's called integration by parts, right? So that time I'll show you how to apply. Because if I show also, okay, you can't easily identify because that method already not done. Clear? So this method also is called integration. Integration by parts, right? So there is a topic. With the help of this, we'll be able to solve. Is this clear to you? Very easy. So now solve these questions. Solve questions on the exercise 1. And if any now any sort of confusion, you can give the comments. So in that next video, I will try to start with the integration by trigonometry.